Okay, welcome to the day 9 of the daily practice. So today is going to talk about the fluid pressure, which is also related to the day 8 practice. So we know that the pressure is defined as the force divided by the area. So if we can use the formula here, we can just use what we have learned before. The buoyant force will be rho multiplied by g multiplied by the volume, right? And then if we divide by the area, the volume divided by the area in a container is just going to be the height. So we have this equals the density multiplied by the gravitational acceleration and then multiplied by the height. So this is actually how we got the formula over here. So you can see that the pressure is only dependent on the depth of the fluid. So if we can know this formula and how we got this, we can then take a look some of the problems. Although the two problems are both from the 2017 F equals ma problems, but trust me, the two problems are not going to be very hard. So for the first one, we have the three flasks, A, B, and C, each have a circular base of the radius of 2 centimeters. So we know the area of the bottom will be the same. But then an equal volume of water is poured into each flask and none overflow. So we want to rank the force of the water F on the base of the flask from greatest to least. So in this case, you can just think about if we have equal amount of the water here, obviously the last one is going to have the largest depths, right? And then the A here is going to have smaller, but we still have more than this B here, because the container B is going to have larger and larger radius, whereas the C has a smaller and smaller radius. So if we just compare the depths, we know that the C has the largest depths and the B has the smallest depths. And because the pressure is dependent on that, just on that force on the depths, so we also have the C is larger than A and then larger than B. So we will have the D here is the correct answer. Okay, so the next one is also very similar to this, although you have to just be careful with some details about how we calculate the pressure. So in this case, we have the handle of a gallon of milk is plugged by the manufacturing defect, and after removing the cap and pouring out some of the milk, the level of the milk in the main part of the jug is lower than in the handle. So in this case, which one will calculate just the pressure of the milk at the bottom? So the pressure here is defined as the pressure just against the atmosphere. So in this case, we only look at the larger part, the major part of this container, which will be the capital letter of the H, because the lowercase h is plugged and it's not just touching the atmosphere. So if we want to calculate the pressure, we have to use the rho multiplied by the G and multiplied by the capital letter H, and that will give us the answer choice B. Okay, yeah, so this problem is only testing that details of the concepts, so make sure you know how we got the pressure here.